let's take a look at naming ionic compounds. So we're going to look at naming simple ionic compounds for binary compounds of a metal and nonmetal. The formula we write is the formula unit, the ratio of cations to anions in the crystal, the lowest ratio. The formula unit represents the lowest ratio of cations to anions that result in a net charge of 0. For instance, if we have Na1 plus and Cl1 minus, we're going to get a formula unit of NaCl, since that's balanced. NaCl, we just read it as sodium chloride. No monos, no dis, no tris, nothing like that, just sodium chloride with an IDE at the end. We have to make sure the charges are balanced. In this case, they are balanced. We have a 1 plus and a 1 minus, that's NaCl. Now we could have something like this, Na5, Cl5. The charges would be balanced because 5 Nas gives us a 5 plus, 5 Cls gives us a 5 minus. This is also balanced, but we always go to the lowest one. Right? Since one of each ion gives a net charge of 0, the compound for this formula is NaCl, sodium chloride. Another example, Ca2 plus F1 minus. We need to get to a charge of 0. So in order to do that, we need 2 of these guys. So we're going to have CaF2. And we're going to call this calcium fluoride. No difluoride, just calcium fluoride. Right? Now, we could have Ca2F4. That also works, right? Because then 2 times 2 is 4. 4 times -1 is -4. This is balanced. This is also balanced, but it's not the lowest version. The lowest version is CaF2. Right, so for naming simple ionic compounds, the name simply repeats the names of each element in the formula unit. Na1 plus, Cl1 minus make NaCl. NaCl is sodium chloride. Ca2 plus and F1 minus makes CaF2, which is calcium fluoride. Now we also have to be able to go the reverse way. Calcium bromide is Ca2 plus and Br1 minus, so the formula unit is CaBr2. Aluminum sulfide is made from aluminum 3 plus and S2 minus, sulfur 2 minus. Formula unit is Al2S3. Right, so there's a couple of examples on the back that we're going to look at. So we've got a metal and a nonmetal. We're going to do the formula and the name. First thing we need to do is identify the charges on these. Sodium is a 1 plus. Fluorine is a 1 minus. So we can just write them as NaF, one of each. And we name it sodium fluoride. Be, that's beryllium. Beryllium is a 2 plus. Fluorine is a 1 minus. So to get these charges balanced, we need 2 fluorines. So we're going to have BeF2. And we're just going to call this beryllium. Beryllium. I don't even know how to spell that. I'm way off. Beryllium fluoride. AlO. Al has a 3 plus charge, and O has a 2 minus charge. Now to get these the same, we have to get them to 6. So we're going to need 2 Als, that 2. We're going to need 3 O's there. So Al2O3, aluminum oxide. Last one, LiO. Li is a 1 plus charge and O is 2 minus charge. To get these balanced, we're going to need 2 lithiums, 1 oxygen. So it's Li2O, and that's just lithium oxide. This is enough of a name to uniquely name this. Right, so let's work these backwards. Potassium sulfide. Well, it's got potassium in it. Potassium's a K. And it's got a 1+ charge. And sulfide is an S with a 2+ charge on it. So 2 negative charge. To balance that, we're going to need K2S. It can't be anything else. It's just K2S. Magnesium oxide. Magnesium's Mg with a 2+. Oxide is O with a 2-. That's going to be balanced, so it's just going to be MgO. Then AlF3, that's aluminum fluoride. So Al has a 3+ charge on it, and fluoride has a 1- charge. And lastly, we've got magnesium phosphide. Magnesium is Mg with a 2+, and phosphide is P with a 3-. Now we got to get these guys to 6. So Mg is going to have 3, and P is going to have 2. All right, so simple binary ionic compounds are pretty easy to do. They're easy to name. You just have to remember to balance the charges. All right, thank you for watching this video.